Good day everyone, welcome to Module 3 of Thermodynamics. For our first discussion, we have the perfect gas law. What is perfect gas law? Perfect gas law is also called as ideal gas law. It is also a gas that conforms in physical behavior to a particular idealized relation between pressure, volume, and temperature. For the formula of perfect gas law, we have PV equals nRT. P stands for pressure, V for volume, N for amount of substance, R for ideal gas constant, and T for temperature. Here are some of the examples for perfect gas law. Number 1 example, we have 2.4 moles of helium gas are at a pressure of 1.70 atm and the temperature is 40 degrees Celsius. What is the volume of the gas? For our given, we have pressure is equals to 1.70 atm. We are finding the volume. For our amount of substance, we have 2.4 moles, and for our temperature, we will convert it to Kelvin. So 41 degrees Celsius plus 273 is equivalent to 314 Kelvin. Then for our ideal gas constant, we have 0.0821 liter multiplied to atm over K multiplied to mole. We will use our formula PV is equals to nRT. Since we are finding the volume, we will cancel the pressure, and in order to cancel the pressure, we will divide both sides by pressure. So after cancellation, we have the remaining formula volume equals nRT over pressure. Since we derived on the formula of volume, so we will substitute all the quantities. So volume equals 2.4 mole times 314 Kelvin over 1.70 atm times 0.0821 liter times atom over Kelvin times mole. Since we have the quantity, to have the easier computation, we will cancel all the same units. So we will cancel the mole, then the atm and the Kelvin. So the remaining unit will be the liter. So 2.4 times 314 times 0.0821 liter divided by 1.70 is equals to 36.40 liter. That will be our volume. For our number 2 example, we have calculate the volume that 13.5 grams of carbon dioxide gas will occupy at a temperature of 40 degrees Celsius and pressure of 1.30 atm. In this case, we're still finding the volume. So our given will be pressure is equals to 1.30 atm. Our amount of substance will be 13.5 grams times 1 mole over 44.0 gram is equals to 0.31 mole. Then our temperature, since we are finding the value of Kelvin, so 40 degrees Celsius converted to Kelvin, it will become 313 Kelvin. Then our ideal gas constant, we have 0.0821 liter times atom over Kelvin times mole. Then the molar mass of carbon dioxide is equals to 12.0 plus 2 times 16.0. So this equals to 44.0 gram over mole. And this solution shows how we find the amount of substance. So we will use our formula PV equals to nRT. Since we are finding the volume, we will cancel the pressure. So divide both sides for pressure. So we will cancel the pressure. So the remaining, and we can derive the formula of volume. So volume equals to nRT over P. Then substitute the quantity. So we have 0.31 mole times 313 Kelvin over 1.30 atm times 0.0821 liter times atm over Kelvin times mole. The same process, we will cancel the same units. So we will cancel the mole, then the Kelvin and the atm. So the remaining unit will be the liter. So we will multiply each other. So 0.31 times 313 over 1.30 times 0.0821 liter. and then we derive the answer of 6.13 liter, and that will be our volume. So for our next example, at a certain temperature of 4.34 moles of carbon dioxide gas at 3.15 atm, take up a volume of 36.28 liter. What is the temperature? So for our given, we have pressure is equals to 3.15 atm. Our volume is 36.28 liter. Then our amount of substance, we have 4.34 mole. For our ideal gas constant, we have 0.0821 liter times atom over Kelvin times mole. So we are finding the temperature. Then we will use our formula PV equals to nRT. Since we are finding the temperature, we will divide both sides for nR. So we'll do the cancellation process. The remaining will be temperature equals PV over nR. That will be our formula for temperature. Then substitute, we have temperature equals 3.15 atm times 36.28 liter over 3.24 mole times Kelvin times mole over 0.0821 liter times atm. So we'll do the cancellation process. So we will cancel atm, cancel the unit of mole and the unit of liter. So the remaining unit will be Kelvin. So 3.15 times 36.28 over 3.24 times Kelvin over 0.821 liter, the remaining will be 430 K. So that will be our temperature, 430 Kelvin. The next topic will be Charles' law. What is Charles' law? Charles' law is a statement that the volume occupied by a fixed amount of a gas is directly proportional to its absolute temperature if the pressure remains constant. Our formula will be V1 over T1 equals V2 over T2. V1 is our first volume, V2 is our second volume, T1 is first temperature, and T2 will be our second temperature. So here are some of the examples of Charles' law. Number 1. A balloon inflated in a room at 29 degrees Celsius has a volume of 5 liter. The balloon is then heated to a temperature of 55 degrees Celsius. What is the new volume if the pressure remains constant? So our given is temperature 1 equals 29 degrees Celsius. To convert to Kelvin, we will add 273, so it will become 302 Kelvin. Then our temperature 2 is 55 degrees Celsius. We will add 273 to convert it to Kelvin, so it will become 328 Kelvin. And our volume 1 is 5 liter. So we are finding the value of volume 2. To solve our problem, let us use our formula V1 over T1 equals V2 over T2. So substitute, our V1 is 5 liter over 302 Kelvin equals to V2 over 328 Kelvin. Since we are finding the volume 2, we need to cancel out the 328 Kelvin. So we will multiply both sides to 328 Kelvin. After cancellation, the remaining will be 328 times 5 liter over 302 equals to volume 2. So multiply 328 times 5 liter, then divided to 302. So the remaining will be 5.43 liter, and this will be our volume 2. And here our next example. If a sample of gas occupies 8.80 liter at 330 degrees Celsius, what will be the volume at 29 degrees Celsius if the pressure does not change? Our given is temperature 1 equals 330. To convert it to Kelvin, we will add 273, so it will become 603 Kelvin. And our temperature 2 is 29 degrees Celsius. To convert it to Kelvin, we will add 273, so it will become 302 Kelvin. Our volume 1 will be 8.80 liter. So let us solve. Remember that we are finding our volume 2. Our formula will be V1 over T1 equals V2 over T2. So substitute, we have 8.8 liter over 603 Kelvin equals V2 over 302 K. To get the value of volume 2, we need to cancel 302K. So we will multiply both sides to 302 Kelvin. So cancel. So the remaining will be volume. Then the other side, we will cancel only the unit. So the remaining will be 302 times 8.8 liter divided by 603. The answer will be 4.41 liter. And this will be our volume 2. Number 3 example, exactly 10 liter of air at 35 degrees Celsius is warmed to 89 degrees Celsius. What is the new volume if the pressure remains constant? So our given is temperature 1, we have 35 degrees Celsius. To convert it to Kelvin, we will add 273 and it will become 238 Kelvin. Then temperature 2 is 89 degrees Celsius. Thus 273 to convert it to Kelvin, so it will become 362 Kelvin. Then our volume 1 will be 10 liter. Remember that we are finding the volume 2, so we will use our formula V1 over T1 equals V2 over T2. So substitute, we have 10 liter over 238 Kelvin equals to V2 over 362 Kelvin. To find the volume 2, we need to cancel out the 362 Kelvin. So we will have to multiply both sides, so 362 Kelvin. So cancel out, so the remaining will be volume 2. Then the other side, we will cancel the unit only. So 362 times 10 liter divided by 238. So the remaining, or the answer, will be 15.21 liter. That will be our volume 2. Our next discussion is all about Boyle's law. What is Boyle's law? Robert Boyle in 1662 states that the pressure of a given quantity of a gas varies inversely with its volume at constant temperature. Our formula is P1 times V1 equals P2 times V2. Our P1 is for our first pressure, P2 is second pressure, V1 is first volume, and our V2 is second volume. Here are some of the examples of Boyle's law. A balloon contains 40 liters of helium gas at 100 kPa. What is the volume of the helium when the balloon rises to an altitude where the pressure is only 30 kPa? Our first volume is 40 liter. Our first pressure is 100 kPa. Our second pressure is 30 kPa. And we are finding on our second volume. To find the value of second volume, let us use the formula P1 times V1 equals P2 times V2. Substitute, we have 40 liters times 100 kPa equals 30 kPa times volume 2. To get the volume 2, let us divide both sides with 30 kPa to have the cancellation process. So cancel 30 kPa on the other side, and the other side we have to cancel the units only. So the remaining will be 40 liters times 100 over 30 equals volume 2. So 40 liters times 100 divided by 30, the answer will be 133.33 will be our volume 2, and this will be our answer. Another example, nitrous oxide is used as an anesthetic. The pressure on 3 liter of nitrous oxide changes from 130 kPa to 50 kPa. If the temperature does not change, what will the new volume be? Our given, for first pressure we have 130 kPa. For our second pressure, we have 50 kPa, and our first volume, we have 3 liters. And now, still we are finding on the value of second volume. Let us use our formula. We have P1 times V1 equals P2 times V2. Substitute, we have 130 kPa times 3 liters equals 50 kPa times volume 2. To get the value of second volume, let us divide both sides with 50 kPa to have the cancellation process. So we have to cancel on the other side, and on the other side, we have to cancel the units only. So the remaining will be 130 times 3 liters divided by 50, and the answer will be 7.8 liters will be our second volume, and this will be our final answer. Another example, a gas with volume of 5 liter at a pressure of 250 kPa is allowed to expand to a volume of 15 liter. What is the pressure in container if the temperature remains constant? So our given first pressure is 250 kPa, our first volume is 5 liter, and our second volume is 15 liter. So we are finding the value of second pressure. So we will use our formula, P1 times V1 equals P2 times V2. Then substitute the following value, 250 kPa times 5 liter equals P2 times 15 liter. To do the cancellation process, we have to divide both sides with 15 liters. So cancel, the remaining is P2. Then on the other side, we have to cancel the units only. Then multiply the following and divide. So 250 kPa times 5 divided by 15. So the answer will be 83.33 kPa, which will be our second pressure. And this will be our final answer. Our next discussion is all about Gay-Lussac's law. What is Gay-Lussac's law? This states that the pressure of a given mass of gas varies directly with the absolute temperature of the gas when the volume is kept constant. Our formula will be P1 over T1 equals P2 over T2. And here are the examples. The gas in a used aerosol can is at pressure of 105 kPa at 25 degrees Celsius. If the can is thrown into the fire, what will the pressure be when the temperature reaches 920 degrees Celsius? So our given will be, first pressure is 105 kPa, then first temperature we have 250 degrees Celsius. To make it Kelvin, we have to add 273. So it will be 298 Kelvin. Then second temperature is 920 degrees Celsius. Add 273 to make it Kelvin. So 1193 Kelvin. So we are finding on the second pressure. To get the value of second pressure, we have to use the formula P1 over T1 equals P2 over T2. So substitute the following. We have 105 kPa over 298 Kelvin equals to P2 over 1193 Kelvin. To get the value of second pressure, we'll have to cancel out 1193 Kelvin. So we have to multiply both sides with 1193 Kelvin. Then cancelled out on the other side, so the remaining will be the second pressure. Then on the other side, we just have to cancel out the unit. So the remaining will be 1193 times 105 kPa divided by 298. The answer will be 420.35 kPa, and this will be our second pressure. And for our next example, we have a sample of nitrogen gas has a pressure of 7.20 kPa at 540 Kelvin. If the volume does not change, what will be the pressure at 180 Kelvin? And our given is, first pressure we have 7.20 kPa, and our first temperature we have 540 Kelvin, and second temperature is 180 Kelvin. So we are finding on our second pressure. So let us solve. We will use our formula P1 over T1 equals P2 over T2. So substitute, we have 7.20 kPa over 540 K equals P2 over 180 Kelvin. To get the value of second pressure, we'll have to cancel out the 180 Kelvin. So multiply both sides with 180 Kelvin. So cancel out. On the other side, we will just cancel the unit. So the remaining will be 180 times 7.20 kPa divided by 540. After getting the product of 180 times 7.20 kPa, you will have to divide to 540. So the answer will be 2.4 kPa, and this will be our second pressure. For our third and final example, we have the pressure in a car tire 3.0 atm is 29 degrees Celsius. After a long ride, the pressure is 3.30 atm. What is the temperature of air in the tire as the volume is constant? Our given is first temperature is 29 degrees Celsius. So we will convert it to Kelvin. So plus 273 is equivalent to 302 Kelvin. Then our first pressure is 3 atm and second pressure is 3.30 atm. So we are finding on our second temperature. So we will use our formula P1 over T1 equals P2 over T2. So substitute, we have 3 atm over 302 Kelvin equals 3.30 atm over T2. To get the value of second temperature, let us perform the cross multiplication. So 3 atm times T2 is equals to 3 atm times T2. Then 302 Kelvin times 3.30 atm. To have the cancellation process, divide both sides with 3 atm. So cancel 3 atm. So the remaining will be the second temperature, the unit of second temperature. Then on the other side will be 302 Kelvin times 3.30 divided by 3. The answer will be 332.2, and this will be our second temperature.
And that will be all for today. Thank you for watching.